Welcome back. In our last lesson, we talked about proving triangles congruent using the angle-side-angle theorem. And in this second part of this section, we are going to look at proving triangles are congruent using angle-angle-side theorem. Now, the angle-angle-side theorem is different from the former theorem that we just talked about because we have two angles and a non-included side of one triangle. So we have two angles like angle A and B, and this side is not the one between the two angles. It has to be a non-included side. And those have to be congruent to the corresponding, so the ones that are in the same position, the corresponding non-included side of another triangle, then the triangles are congruent. So here's an example of what the diagrams would look like for two triangles where angle-angle side would prove that the triangles are congruent. So the proof of this angle-angle-side theorem is kind of interesting, and you'll see when we get to the end of this. If we're given angle A is congruent to angle D, and angle B is congruent to angle E, and side AC is congruent to side DF. So we're given those three pieces of information, and if we go ahead and write those down in our proof that those are our givens, the next thing that we could say is we can say, well, if we know angle A and B are congruent to angles D and E, we also had a theorem called the third angle theorem that would say that angle C is congruent to F. That was our third angles theorem. So now we have an angle, an included side, and a third angle, or a second angle. So that was the angle side angle that we learned just in the last lesson. So the proof of the angle-angle side theorem actually uses the angle side angle theorem. So be careful you don't confuse these. One of the ways to remember which one you're using, angle side means you have two angles and the side is not included. It goes AAS because the S is not between the two A's. On the angle side angle, you'll notice the S or the side is between the two angles, and so that's how you can differentiate between those two theorems. Just look at the order of the letters. So let's go ahead and work on writing a proof using angle-angle side. We are given that angle M is congruent to angle K, so that's a given. We are also given that side WM is parallel to side KR or RK. That's also given. So that's all we're given, and we want to prove that these two triangles, WMR, is congruent to RKW. Well, we've only got one angle so far, so we need another angle and a non-included side, or we could do two angles with the side included. So these two angles, angle MWR is congruent to angle KRW, these two. So let me mark this for you so you can see what I'm talking about. Here we go. So this angle right here would be congruent to this angle up here. And why would those two angles be congruent? Well, if you remember, we have these two sides are parallel, and so those two angles are alternate interior angles. So your reason or your justification for that will be if two lines are parallel, then the alternate interior angles are equal. You can just write alternate interior angles, and that's good enough justification. We also have that side WR is congruent to itself. That's the reflexive property. Every side is congruent to itself. So now if you look what we have that angle M and angle W. So we have two angles, and then we have this side right here is congruent to itself. So we have angle side, and in this one we have angle side. So then we've proven that these two triangles are congruent by the angle side congruence theorem. Here's one for you to try on your own. Go ahead and pause the video and we'll work through this together when you come back. All right, I hope you took some time to try to give that a try on your own. That helps your learning when you try these by yourself. We're always going to write our given statements first. So you'll want to write angle S is congruent to angle Q, and that is given. That's your reason. Okay, we also have that RP, segment RP, bisects angle SRQ. That is given. And let's go ahead and write, we already have it indicated in our figure that those angles are congruent. What does it mean that RP bisects angle SRQ? Well, the definition of a bisector, if it bisects the angle, that means that the angle is split exactly in two equal parts. So then we're going to have this angle right here. We'll put two little hash marks on that one. Is congruent to this angle here. And that also gets two little hash marks. So those two angles are congruent. So now we can put that into our proof. We have angle SRP is congruent to angle QRP. Now be careful with the order of your letters. Remember, these matter. QRP. What's our justification for that? Why are those two congruent? Well, that's just the definition of an angle bisector. So you can just write, and I'm going to abbreviate the word definition. Definition of angle bisector. So what do we have now? We have two angles that are congruent. Well, we need a side. Well, if you take a look at your figure, we have side PR is congruent to itself, right? So we could say that segment PR or RP, however you want to write that, PR is congruent to PR. And what's our reason for that? We've used this quite a bit. This is the reflexive property. So do we have enough information yet? We have two angles and a non-included side are congruent to two angles in the corresponding non-included side. So we're ready to say that we've got all the information that we need to do our proof. So we can say triangle SRP is congruent to triangle QRP. And our reason for that is we have angle, angle, side. Two angles and a not included side. In these next couple of questions, we are going to determine whether the triangles that were given in the figures are congruent just by the markings on the triangles. So let's take a look. We have angle B congruent to angle U, angle I congruent to angle T, and then they're telling us side BF is congruent to side TO. But if you look at these, the two angles are okay. We've got those are congruent, but the sides don't correspond. In order for these triangles to be congruent using angle, angle, side BF would have to correspond to side OU or UO. And that's not the case. So in this one, the answer is no. These are not corresponding sides. So that's the one you would color in right there. It's definitely not. Okay? How about number 4? Are triangle PAR and SIR congruent? PAR and SIR? Well, we have angle A congruent to angle I, so those two correspond. And then we have side SR is congruent to side PR, and those two correspond. So you might want to just take a look at, P and R, those two correspond, these two correspond. So we have an angle and a side. Well, the other thing that we can say is this angle right here is congruent to this angle here. What would our reasoning be there? So put two little hash marks there. Why would those two angles be congruent? What would your justification be? And those two are vertical angles. Hopefully you recognize that those are vertical angles and they are congruent. So now we have angle, angle, side, angle, angle, side. So yes, they are congruent by angle, angle, side congruence theorem. Here's a lesson check for you to do. Bring your answer to class and we'll talk about it tomorrow. See you next time.